As always, you know the drill. This is an audio check with one microphone and another audio check with the second microphone.
Test, test, 1, 2. Hello, can you hear me? Test, test, 1, 2. Can you hear me now? Me? Okay.
So. Now I'm in the picture. Okay, good. Happy New Year to you all. Happy 2026 first meetup January here at Rubicon. Thanks all for coming. As always, the meetups are organized by us.NET Devs.at. We are a non-profit organization here in Vienna. You can find us everywhere. Yeah, thank you all for joining here today and on stream. Hi. And hi on the recording. Thanks to Rubicon for hosting us again here. It's always a pleasure to being here. And also thanks for Rubicon to sponsor us financially, that we can do such things with streaming and recording and preserve all the stuff, the knowledge we have here afterwards. Also thanks for JetBrains for sponsoring our 12 months product license. As usual, we make a raffle for this. How you can take part in it, you type hashtag JetBrains in the chat. Also for the people here in the audience who want to join the raffle, the easiest way is quickly join on your phone and enter in JetBrains. We do the raffle after the talk. Some quick community news for our next meetups. The next .NET meetup is on February the 19th. It's Evolve with modular monoliths with architectural fitness function. I need to talk with the speakers about a better title. With Patrick Sal and Tim Paulus at Tech Talk. This time it's a Thursday, not a Tuesday. Meetup events will go out probably next week. And somewhere in March, we don't have yet an exact date, Shahab Ganji from Square is talking about Kafka through the lens of .NET. One additional thing that I forgot to put on the slides is next week is the AgentCon in Vienna. It's a free conference about agentic engineering. It's, I think, the 27th or 29th of January. Yeah, AgentCon Vienna. You will find it in your preferred search engine. And yeah, if you also want to host a meetup, get in contact with us by email, team@netdev.at, or talk with us after the session. Us is Raul, Stefan, and me. Always have new locations for hosting. And with that, I'm done and happy. I have a bad timing. And I'm happy to present you Alex Thyssen, flown in today for his talk, DevContainers Development Environment as Code. And with this, the stage is yours, and also the HDMI cable. Small technical interruption.
It's on. Yes, it is on. All right. So thanks, everyone. I'll be doing this in English. I think, I can manage a little bit of German, but I won't bother you with it. But thanks for the invitation by .NET Devs in Austria. Wonderful to be in Vienna again. It's not my first time, but I enjoy the city very much, so it's not too bad to fly in here and do this session with you. It's about DevContainers, something that I really like, and I just want to share the things that I know. We have about an hour-ish, this is what they told me, time frame to talk about some things. I am from the Netherlands. I work as a cloud architect, but I go by many roles and names. This is just what I chose recently because I like working with the cloud and doing cloud native stuff. But in my heart, I'm a developer, and I like to make it as easy as possible. And also, you know, what I know, I share, so you can have an easy life as well. So we'll go through some scenarios. We might skip some stuff, but it's depending on what you know, and we can't ask the people online, but we can definitely ask you. Who's worked with containers before? That's almost everyone. Okay. Who's worked with DevContainers before? That's just a few hands. All right. So containers is fine and good, because then you'll know what it's all about and how that works. So let's see if we can start doing the first few things. All right. So just as a very ultra fast demo, just to get started with people that have never heard about DevContainers before, and development environment as code. Let me show you the following. And I need to find the right thing here because I have a browser open somewhere. There. And then I will go here. So there was a few years ago, I wanted to do a blog and build myself a website, and people said, you need to use Jekyll, because Jekyll, you know, that's really easy. You just write stuff in Markdown, and then you can generate your website over and over again. And I looked at this, and the things you needed to do, it's like you need to install Ruby. So there's a lot of instructions to install Ruby. Then there's things like other things you need to do, install, run the scripts, and do many things before you can get started. And I was like, okay, this is not for me. And putting Ruby on my system, which I will never use, but just for the sake of generating a website, I thought, no, better not do that. But then comes DevContainers, and DevContainers, the idea is that you can prepare a container as your development environment, or your environment that has all the dependencies, framework things that you need to do something. So in this case, it's Jekyll. Now, just to show you how easily you can do this, it's short, but and just let me know if this is too big, because we blew up the entire screen size and the font size. But let me open a folder here that I prepared. So this is .NET Devs website. It's an empty folder, and there's nothing in there. In Visual Studio Code, you can work easily with DevContainers. We'll talk about other scenarios as well. But you can add DevContainer configuration files, because it's files that define your environment. And then you can say, okay, where do you want to store those configurations? Well, let's do the workspace, so which means the folder that we're currently in. And then we will search for Jekyll. And it says, okay, there's already a Jekyll-based DevContainer. It's one of the approved ones from the maintainers of DevContainers. So we'll take that one. You can choose your Debian version. We'll go with defaults. You can do many other things, features, and we'll talk about features as well. We'll skip that, and you can add additional files. We'll skip that as well. So make it really simple. And then it immediately pops up with saying, you know, reopen this in a container, because all of a sudden we have this special file, devcontainer.json. And if we reopen in container, all of a sudden, it will be opening a remote. It will download an image, the image that was specified at the very beginning. We have an empty folder still, but in the bottom corner, you see DevContainer with Jekyll. No, so suddenly we're connected to something. All right. Now I need to do some real estate management, but let's go to a terminal. And then you can do something like Jekyll all of a sudden, which I couldn't do before. You know, Jekyll wasn't installed on my system. That was clean. I have Jekyll. I can do Jekyll and then say new, skip bundle, which is something that I looked up, right? I don't know this, but it's all of a sudden generates all these files, and I can do Jekyll serve. And then it says, okay, it does things. There's a little bit of warnings. We have a port open, and then we can say, okay, open it, and ta-da, I have my website. And everything that I needed, like Ruby and installing Jekyll itself, it was all done for me. And when I close this down, so when I just close this down or disconnect the remote connection, it's gone. But in essence, it's a container running in the background that we've connected to it. So that's kind of how easy it is to get started. And there's many of those starters where you can do Jekyll or ASP.NET Core, or even home automation with home assistant development. There's so many things out there to get you started. It's easy, but we're developers, right? So we want to know, how does this work, and how do I use it for my development scenario? Because I'm not doing Jekyll. I don't either. Well, sometimes. All right, so let's get back. Because I hope you recognize some of the things here with development environments. Maybe quick poll. When you think about the last project that you were onboarded onto, or the new job you started, how long did it take you to get started where you could build something and push it out, commit it so it went to the test environment, maybe even production? So who's saying I could do that within a day? There's only a few hands. Within a week. Keep your hands up, please, because then we can see. All right, a month? Oh, okay. So there's even people that it took a month. And this is not uncommon because it's a lot of things, huge installation documents. Sometimes it's also getting the IT department to help you out with setting up accounts. This doesn't help you there much, but still, if you can do isolated work, that would be fantastic, right? That you don't need to have an internet account, but you can just get started. Clone a repository, just imagine, press F5 or just run it, and it will build and run itself with everything possible. And we will work through a scenario where we do so that is, well, pretty much that where you would need an Azure environment, but you can do running it all locally, even though you would have normally had dependencies on cloud. All right, so it's a few things. The setup time we just discussed. How long does it take you to get started to prepare your machine? And this is not an easy thing because maintaining versions, if you run something in Python, it might be Python 2 or 3, or maybe both. And it could be .NET versions that you have running, or Java SDKs that need to be installed. And how do you maintain versions or switch them? Or what if one doesn't allow the other one to be installed? So complicated stuff, because it all needs to be on your machine, and your machine just gets bloated. We need a solution there as well. If you want to work remotely, maybe even without your own laptop, would it be possible? Could we just use a phone or a browser to do our work and do it somewhere in the world? Yes, you can. And then for the teamwork, the installation guide on setting up your machine, there might even be different versions for the front-end developer and the back-end developer and other roles within the team. They have, they're different, and they need their own thing. It's also about personalizing it, because I like to have my terminal window in certain colors or themed or whatever, my environment as well. And I want to change that and not be dependent on what somebody else thought. So that helps. And then if you figured out how to set up your machine, how can you share your things? So in this case, you can imagine it's sharing those files, but just sharing them as files is very fragile. So is there a better way? Well, there will be answers to solve everything. Well, not everything, but most of the things that are here. So it's a pretty cool thing. I'm very excited about the DevContainers. Use it all the time. That's what the car salesman says, right? I use it at home as well. All right, so I thought of doing this demo as well, because I think if you grasp this, and most of you have container experience, so I'll try to go as fast as possible. Doing C++, and we're all .NET developers here, right? Who's done C++? Oh, okay. Well, cool. But let's see what we can do there. So I will go to this window here. All right. So, and now I hope that I still have, yes, I do. So I created a folder on my F drive that's called hello. It should be empty. Let's see. This is kind of an important part. See, it's empty. And we'll put this in front so we can see what's there. And I will run a container name that's called, let me just make it a little bit larger here. .NET Devs Demo. It's an Alpine, and I'll start sh, you know, the bash, the terminal window. And I mount a volume. So I'm mounting this folder here that we see in the back to /user/.NET Devs, this one here. So it's mapped from my machine into the container, so we can get the files in and out. And if I do this, oh, let's get rid of it. Let's do demo. It's taking long. All right, so we're inside the container now, and you've seen this before, right? What can I do? I don't have much. I don't have, we want to do C++, so I need a compiler. Don't have it. I don't have Git. I don't even have curl, so I can't do it. It's Alpine. It's only 6 megabytes. It's an ultra small thing. Nothing in there. So let's first go to the user.NET Devs, and then say something like echo hello to hello.c. You see it at the top there, it's small, but you see that the file also appeared locally, right? Because it's both worlds, like a tunnel in and out of the container. Why is it important? Because if you don't do this, you need to be very careful that if you destroy your container and all your files are only inside of the container, you will lose your files. So it's either git, commit, and push it out to store it safely, or have it on your local file system and have the container look at your local file system. Otherwise, you'll just lose stuff. So this is one of the scenarios you can do, and otherwise, no, git and just make sure you push things out. All right, so let's do APK update, and then APK add. We talked about curl, git, nano, which is an editor, GCC, MuzzleDev, which is some libraries. I believe it's MuzzleDev. Yeah, the make. Let's do make as well. So we'll install all these things, and then we're in a better place to get started. But see how I'm doing all this preparation work to get this installed. I think you can imagine that the next step would be to not make this repeatable, so we don't have to do it again. And since most of you have seen containers, this is all on top of the Alpine. So it's a new layer that we're creating, but we're not committing it or anything. So when we destroy this container and we run the command podman, which could have been docker run, right, or podman run, it will be empty again, just like when we started a few minutes ago. But now we have stuff we can do, right? So, for example, GCC, no input files. Great. Let's create something fast. hello.c. Let's get rid of this. And I hope that I have it in my clipboard somewhere. There. Hello world. Save this. Yes. To hello.c. And now we can do output it as the hello, that's the executable. This Linux, we're inside of a Linux container, and then do hello.c. And then we can run hello, and we're C++ developers, right? So this is how we can work with this. Now I'll do a magic key press here. I'm not sure if you know it, but it's, I think, a well-hidden gem. If I do Control P, Control Q, I step out of the container. So I'm back at my command prompt on my local PowerShell again, but the container is still running, and we'll leave it running for now because it's for the next step on getting things to work. But so we've prepared an environment. We did some work. We need to make it repeatable, but this is the essence of a dev container. That you have this container well prepared and you can share either the image or the way to build the image. And that's what DevContainers is about. So the rest of it is just more details. You've seen it now. And the magic is gone. This is what you'll be doing with DevContainers. All right. So Visual Studio is pretty cool because with this container running now, we had a Windows terminal window to do all the work, but probably you want to work with something more of an editor, maybe an IDE. So Visual Studio Code can do this. It can work with a lot of things that are remote. So it can be SSH, like things that have an SSH entrance possibility can be connected. Remote tunnels. If you haven't looked at DevTunnels yet, please have a look at DevTunnels. Windows subsystem for Linux and DevContainers. Obviously, DevContainers is what we're looking for here. All of these things can be installed inside of Visual Studio Code with the remote development extensions. And that's what is called an extension pack. So it's like a bundled thing, buy one, get four, where you have all the 4 extensions immediately installed if you just install the one remote development extension. And you'll get a remote explorer as well, which is kind of, it's multiple things, but it's also the little blue box in the bottom corner that we saw earlier on. And the remote explorer can connect to all of these, which is very convenient. You just say, I want to connect it to either of these things, and it will enumerate and show you what is available to connect to. There's more. If you install GitHub extensions, the remote explorer will also show you GitHub CodeSpaces and GitHub repositories, and also Azure repos. And that allows you to just point to, for example, a GitHub repo, and it will immediately clone it, spin up an image, and you can start working with the code or reviewing it, testing it, without having to do git clone from a command line or doing other tooling. It's all done for you. But the essence is still, they will give you a dev container just based off of a cloned repo that is cloned as a volume inside of your dev container. So that all works. Very good. Not everybody has Visual Studio Code, so that's okay. There is a CLI that's underneath, important to know. If it's GitHub CodeSpace, they will use the GitHub CLI, and we will focus on this part, but I wanted to show you that there's other things as well. So you can use NeoVim, IntelliJ, or Rider as well. They have support for connecting to those dev containers as well. Not all the other ones, but dev containers for sure. There's even Visual C++ that can connect, but it's only Visual C++ for C++ projects. I haven't met anyone yet that really uses that, but it is a possibility. I excluded it here because it's so niche. So connecting to any container, we have the Alpine now, which has just a few things in it. How can Visual Studio connect to any container? Well, first off, there are some prerequisites. It's listed what the container needs to have. But once it does, and Visual Studio Code knows which container to target, it will inject or insert or upload into the container a Visual Studio Code server, which starts hosting and makes the connection between the editor and your container possible with a rich interaction. So you can see what's inside, and everything lights up in Visual Studio Code as if it's local. It will be installed in this location, depending on the user that is being connected to. So if you have a dev container, they make this special user called VS Code. If you connect as root, it will be root. If you connect as your name, because it's a custom user that you create, it will be Alex, for example. But they will create this folder that's either VS Code server or a dot folder with the dot in between. They will put in some default extensions because, it's a best guess of if you connect just to a container, they will do these things for you. But you can configure those things. It will have local folders. It might have mounts if you have the mounts done like we did, the volume mount, or a bind mount is what we did. And then you can have ports. We saw the 4000 light up as well. That also becomes available. All right, so short demo with this empty thing here. So if I go to the bottom here and I click it, I get this thing where I want to connect to. And there's a variety of things, and you see at the left side over there, you see remote tunnels, WSL, remote SSH, the ones that we saw in all the arrows, all the things are there. So we can say attached to a running container. If we go there, it says .NET Devs demo. That's the one we started. It's there. So we can just connect to it. And it will do some things like inserting the VS Code server. So it's uploading those things, getting things started. And before you know it, you have your file there. And it's all neatly done, right? It has even color highlighting. It knows about C++. It has this thing here, the make file. You might wonder, wait a minute, but how does it know that it's C++, this extension needed to be there? I'll tell you, because otherwise you might wonder afterwards. But if you go here and you do DevContainers, and then I believe it's the open container configuration file. We saw earlier on that Jekyll had a DevContainer JSON, but we don't have it here. But there is one hidden based on the name of the image you use, and it's an Alpine image. So if you look at this one, it says, you know, this thing has a naming convention of Alpine latest JSON and some other things in front of it. But you can see here that I put in here this makefile tools, and I also told it to use this as the workspace folder. That's why it neatly opens the right folder where we had our code, not just in the root where we had all the other stuff. We needed to do CD, user, and then .NET Devs demo. Now we don't, because this is here. And it will just pick up based on the image name, because it's not a full dev container yet. It doesn't have a dev container JSON. All right, moving on, because we've got more stuff to do. So when I'm connected here, I can say, you know, I want to do other extensions and install those as well. But I will install them on my Visual Studio Code in general. So it will just get bloated as well. So it's not just installing all frameworks and runtimes on my local machine, but it's also having Visual Studio Code have all the extensions that I might ever need, but I just need the C++ one now. I don't need it later on. So let me just disconnect from this one to prove my point. Close remote connection. And now we see that it has other ones. And these ones I chose intentionally because this is the Remote Explorer. If you go here, you can see at the drop down that you can choose all of the things that you could connect to. And it starts showing you these things. So that's convenient to have. Running containers, where we have, for example, let me get rid of your images, other things. But these are all the things that I have opened. Sometimes I clean up because there's just a lot of stopped containers that have been running. But this is the one that we are using at the moment. This is the one running, and the files that are in there, we can even see that. So that's the VS Code server doing that for us, right? So showing us the insides of the thing. So everything as code, that's kind of where we want to go to, because a lot of manual work still, not really full-fledged, taking into account that we want to combine everything. So the scenario that we'll work to is, what if we're cloud-native developers, and what if we use Azure? You might use Google Cloud or AWS or Alibaba, or, you know, it might be something different, but just imagine that you can do similar stuff with your cloud. But I'm more comfortable with Azure, so I chose that one. On your machine, you would normally have all tools, frameworks, and dependencies installed. And if we want to get away from that, just to work with Azure. So we'll move that to the side. And we want to have a machine that has container support, because you can't do dev containers if you don't have a container runtime installed. Docker Desktop works. It has a license where there's if you use it professionally, you need to have a license there with payment. Podman is also pretty cool, which is free. So whichever one, you know, professional setting, you can choose either one. Just know the consequences. And at home, hobby projects, you can do whatever you want. So we will run containers and do the stuff there. So everything that we install, we stop installing it on our machine. We start installing it in a container, and that's our dev container. So the dev container will be the one contacting Azure. when we get to that point, instead of our machine doing it. So everything is inside of the container, and Visual Studio Code or any other tool that you pick that is capable of connecting to containers will do the connection to there and make it seem as if that is our development machine, but it's our developer environment. And then we can configure Visual Studio Code with all the extensions, things like personalization of the terminal that we think are good for this scenario. And now we're becoming cloud native .NET developers where we flash in Azure. So that's going to be installed in Visual Studio Code. But again, not the ideal situation because we want that as part of our development environment. And also all the definitions there, which image we used, how that we have lifecycle hooks to do other things like install scripts at the beginning, the ports that are available that we want to have surface and nicely labeled. All those things, we want to define those as well and capture, just like infrastructure as code for cloud infrastructure, we want to capture this development environment as code, the title of the talk, right? So that's what we do next. So container support is a given now. Let's start defining all the things that are on the right side, the tools, frameworks that we need, the base images that we have. So let's start defining that in a file. And then we can also put in your entire dev environment as code by also doing the configuration of your IDE for Visual Studio Code or Rider or CodeSpaces if you do it in the cloud and hosted. You can put that all into that single thing. And that's the DevContainer JSON. But we'll go beyond that. So this is not where we'll stop. But this is important to understand that you can do a lot of things inside of that file. Important to know what it does under the covers. The DevContainer JSON, what's inside there is a specification that has been formed. It originated from Microsoft, but now it's being adopted and it's publicly carried with open source. So you can join, you can read it, you can contribute. And there's also a curated list of the things like Jekyll and Home Assistant and other templates and features is what they're called, that are reachable from the UI. When you say, I want to do a new DevContainer files, you saw that there was a searchable list of all the things available. You can put your things there as well by making a pull request, and once it's vetted, it will appear there as well, which could be very nice. If you don't want to, that's okay, because maybe you don't want your internal development team tools and setup available publicly. But if it's like your pet project or you are maintainer of a framework, you could put it out there as well. All right, so let's loop through the things that we've seen. So far, it was just these two things. A folder that's called .devcontainer. Inside of it, the main file, devcontainer JSON. And that defines our entire DevContainer right there. There are other things. So you can go to a Docker file and define how you build an image from there. So that's where you take control instead of relying on a pre-built image. You can do Docker Compose as well, which we'll do later on, where you say one container is not enough for me. I need other containers to help me out, like maybe an SMTP server to support sending mail from local development, or maybe an emulator for something. And probably you'll have some scripts as well to do some post-startup or during creation of an image, some scripts that install things for you. Where you're like, okay, every time I start, I need to do, create .NET developer certs when I start clean. I need to trust the things. You've probably done it. .NET, HTTPS, dev certs, create, and then, you forget, but you can put it in scripts as well. Optional, but you'll probably start using them pretty soon. So we'll build this. This is like a trilogy of building the DevContainer JSON. Most importantly, give it a nice name. That's what appears in the bottom left corner. So you can quickly see, okay, this is the container that I'm running in. Might seem trivial, like I know what it is, but there are possibilities to have multiple container definitions inside of a single code base. We'll get to that. And then you pick your image. So in this case, it's obviously .NET 10, the latest one. Probably pretty common. You might think, why would I need it? Well, but this one, maybe not so much. You'll likely have it installed on your local machine as well. But what about .NET 8 or 7? If you still have a code base that uses it, you can just change the number and it will be installed only on your dev container and your main system stays clean. It's just files, so in this case it doesn't really matter, but it's about the idea that you don't really need to install everything on your local machine to get started. Those base images, Microsoft has a few. You can see the origin is the Microsoft Container Registry, mcr.microsoft.com, and they have a set of base images for the dev containers, which is everything cleanly prepared and agnostic of what you might do with it. So there is no .NET installed, but certain tools like we did, like GCC and Git and curl, those have been installed inside of these container base images. And they have various flavors that you pick with the tag of the image. So there's lots of variations of the base image, versions and specific for Alpine, Debian, and Ubuntu. So as a few examples, you have base 1.1.0, which is a certain set of tools and versions that are installed. So it might be Git 11.4, GCC 14.2, that combination you can find, but usually you just want latest. But if you want to pin it and be exact now and later in time, you need to give it a special version. You can pick by version, like Ubuntu and a certain version, like, or Bookworm, if it's other distros, you can just choose. And in these things, some of the things you'll get is a non-root user. So this VS Code user will be installed. Z shell, oh my Z shell. That's the the pretty prompts in your terminal, and a lot of tools that you need as a developer to get started. For example, Git. So those are all there, and you can still switch to root, but in general, I think it's a nice exercise to stay away from root, because then you don't have the highest privilege in your, well, if you need root, then it's a sign. You can always do sudo, right? And then elevate privileges just for running a script. But if you need to run under root, think about it again. So these base images by Microsoft, there's a lot of other ones by other vendors, people like yourself. You can build those images as well and use them. We first saw we can use a regular container to build a dev container, but quite fast. I didn't demo this for the sake of time, but just imagine that all the things that I did, like APK update, APK add, and then all the things I wanted, I can put it in a Docker file as well, say from Alpine at the top, and then say, okay, run this Docker file, and it will build the image, and we can get started with developing from a Docker file. So just imagine that we had done that. 2 is probably more repeatable because I can store and share the Docker file. But I can also build images from it. So I can pick one of the base images, or I can build my own one and store it as an image, push it to a registry, and I can always get it back again, like Microsoft did with their base images, and others have done as well. But if you have a base image, you can also take that as a starting point. It's base image for a reason, right? So you can use a Docker file to say from mcr.microsoft.com, blah, 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 DevContainers base. That's where you can also get started and then do the additional wire up of it, more tooling and more things that you need inside. And if you need multiple containers, it's Docker Compose. Then you do a composition and you just say, okay, these are the containers, multiple containers, and this one is my dev container, and the rest are just helpers. So let's take it a step further, part 2 of the trilogy, and let's add features, because some of the more complex things to install, like I can do a APK add curl, but you sometimes need to do more. And people have done installation scripts and made those reusable as well, specifically for dev containers. And that's all in the specification that I showed earlier. So these are just a few examples of things that you can do if you're a cloud developer, and maybe you use Terraform, maybe you use Bicep, that's up to you. But in this case, we're using a feature called Terraform, and it's just a zip file they download from a container registry as well. It's not an image, but it's a tarball. And it has, and when they unpack it, it has an install.sh, so an install shell script. And that will do what needs to be done to install Terraform, or Azure Developer CLI, or the Azure CLI. You know, and just imagine you can just bolt these on by specifying the features. And if you start this dev container with this definition, it will take the base image and download it if it's not there. And then it will start downloading the packages, unpack them, and run all of these install scripts as root user. So that's during installation, you're still root. And they will put it all in the image. And finally, they will say, okay, this is the new image that we've created. And they connect to it.
Quick question. How do you find these features?
Thank you. Questions are welcome, so feel free. How do you find them? Let me find a container that is running. Oh, wait, I didn't even need to do that. Sorry, let me try again. Open folder. We'll go back to our website here, just as an example. So how do you find these features? There's a couple of ways. So I can do, again, add dev container configuration files. There's already one there, right? But we'll just start sort of the wizard again. So we'll say add to configuration to workspace. This is where we choose a template. And I left that out of the slides, but when you get the slides, there will be a couple of slides that are hidden now, but it will show you templates that are in essence a dev container JSON with placeholders that they substitute with the choices you make. So let's do Alpine now. So we'll get rid of the files for things, but let's do this one. This is something that you choose that gets put into, and I'll do 320, not the default one. And this is where the features come in. And then I can say, I want to have Terraform. And then you need to see which one. So Dev Container Extra is also a pretty well-known one. There's also individuals that build things. So make sure that you pick a trusted source, but it's a vetted list. If you go to containers.dev, this is the website with the specification. You can also find the features here. So here you can also say, I want to have bicep. And then it says, okay, this is by a certain person, or Azure CLI, or just do Azure, and you can find your features, but they're equally discoverable here by doing Azure. So it's kind of the same thing. The list that is there is the list that is fed here. This took me a while, and I can't go back in time to find out if this was a new feature or not, but it says, for example, here, let's go back one more. This is important if you start building your own templates. It says, or enter a custom template ID. So if you build your own templates that are not listed publicly, you won't find it in this list, but you say, okay, but I built one, I put it in our registry, I want to have this thing as well. You can just paste it in here as well, and it will get your template. Again, we didn't talk about template, but think dev container with placeholder that they put in the choices that you make. And the template defines which choices you can make and which defaults are there and which choices are available. Like we see here, this is a choice with 3 options and a default. And that's what you put in a template, and that's pretty much it. Or maybe some accompanying files. So if we skip this, you can put in your template a set of files that you can inject into the code as well, because they come from this template and just as an extra. So if we do, yes, we want this, and say, okay, probably the rest will still be here. This will be overwritten. So I will say overwrite. Let's say, okay, I will get rid of this one. But if all goes well, we should have the other file as well, the GitHub dependabot. There it is, from the template. So long answer, but this is where you'll find them.
Thank you.
So we did cover a bit about the features. And again, templates, same thing. You can find templates here as well. So if you have something like .NET, you can see that you find those as well. You know, .NET things like C#. All right. Yes. So many features. We talked about that. We talked about this, that we can find them here. So already covered that. In the common utils, which is what is installed in each of the base images that Microsoft provides, they have this thing called the common utils. As an example, there's a huge list of all the things that are being installed. So if you start from Alpine, 6 megabytes or something, maybe 8, you know, it grows over time just a little bit. It's extremely small. But if you pick the Alpine base image for a dev container, it's like a couple of 100 megabytes because of all these tools. You'll need them anyway. If you don't want it, you can see how they install the things here and build a leaner, meaner version by just starting from Alpine and a Docker file again. And then you're pretty much in the same area. Features also have options that you can define in the dev container. So you can say, for example, in this common utils, these are defined in its template that you can say, you know, do you want Z shell at all? And you can say false. So then it won't get installed. So it becomes a little bit smaller for this feature. But since it's in the base image, Microsoft has already chosen this for you, right? So this would be more typical if you start from a clean Ubuntu, Debian, or Alpine image. You can see where they come from. The container registry, so in this case, GitHub container registry, might be mcr.microsoft.com or your own internal private one. That's the user or the organization. And then the features is the repository. So you'll see things that exist emerge in the name, and then the name of the feature and its version. And then the rest are options that you could consider properties, key value pairs. So we have a huge list of all the things of the features that we define. So usually a clean base image with the common tooling installed, and then we just bolt on all the other things that we need. And then there can be many things defined there, but to just look at the image, the extra features like runtimes, frameworks, and so on, that usually features, and then your Visual Studio Code goes into customizations. So you can do tool-specific customizations for Visual Studio Code. For Rider, the thing will be Rider, and it will have different properties that you can influence. And in GitHub CodeSpaces, you can't influence that much, but that's like running a dev container in the cloud and connect it to that as well. And I'll demo that later on. So a short thing about ports, because ports will start appearing inside of your dev container when you start hosting things. Just imagine, you know, if you do .NET Aspire and host a dashboard inside, it will have a reachable port. We want to see it from our own laptop, right? We can't see it inside of the container because the container is just a Unix thing that is inside of the container. But the Aspire dashboard is viewable from a browser, but it needs to be let outside. Well, they do that automatically, so it's automatically exposed. But you can do some more to make it nice, so that you can easily understand that like port 13389 or something is the dashboard. And especially if you have multiple, like you see over there, if for example, you do things like Radius and Dapper, you know, you might say, I don't really know what it is. Your fellow developer can define this by saying, you know, forward these ports automatically. So it's pre-forwarded. They will show up in the ports section, but they will be hollow. And as soon as they are actually hosted from inside the container, they will light up green. So you can see, the port is not available yet. Oh, now it's available. Small thing is to pre-announce that those ports will be available. So you can easily connect to it. Some of them are automatically exposed when they light up. If it wasn't known yet, you can still reach it. It's not like you're locked out. That would be very difficult to be or unworkable even. But this is the other nice stuff. You can say, if you're automatically forwarded, do I want to have a pop-up like, oh, we've got a new port available in the bottom right corner. That's one thing. You can also say silence. You know, don't announce it. I don't care. So you can less noise. You can label them, so you can see with the port what the intent of the port is. I've got a picture. So for example, you see the hollow ones are not available yet. You can obviously do them manually and then put them in there yourself, but you can put them in the forward ports. If they light up, they become green. But these, like 3000, now you can see that's my backend, or my radius dashboard at 7007. And then you can see at the very end, the origin. These were announced beforehand, like forward port. So that's why they are origin from DevContainers, auto forwarded. And this is one that I did manually. I think this is important because let's face it, usually we build a front end or a back end. So it's HTTP is very, very common. And this will help you out. All right. Oh, yeah. This is new. Yeah. Out of nowhere, right? So you have MCP servers as well. Who's been using GitHub Copilot? All right. Did you configure in your extensions and then went to MCP servers and added them to your local machine? No? Let's see if we're talking the same thing here, right? So if we go here, extensions, then at the bottom here, you see MCP servers installed, and I can search for new ones. And I can, say I want to use GitHub, for example, and then install it. Then I can install it on my local machine for everyone. So every project for me, that's for everyone. Every project, I can install it in the workspace, which means inside of an mcp.json that's in my code base. But we were talking about, this if we have certain special, and I'm a front-end developer and I want to use Playwright, I don't want to install it in my workspace, in my code, for example, because somebody that wouldn't be doing the front-end development wouldn't need it, the MCP server. And if you do a lot of MCP servers, after a while, you get these messages like there's so many MCP servers and tools, it might not perform as well. So that's why you want to be very selective with what you have. Well, guess what? Fairly recently, you can put them in your devcontainer JSON as well. So, how to do that? It has a certain section, the MCP section, that will get copied on the fly when you start your container into this mcp.json in a special location, but it will be automatically generated for you. So, in your customizations, Visual Studio Code, put in MCP, and then put the things in there that you want to have as additional MCP servers for your project, your work. And they will be looped in. And if you disconnect the dev container, it will be gone again. So no MCP server bloat, because otherwise we would have all the MCP servers on our local machine as well. You can work with sensitive data. So they've taken that into account. So if you have API keys and stuff, you don't want to have those in your dev container JSON, because that goes in your code base as well, right? You don't want to expose it. So they have a means of when they see this and it starts up, it will ask for, okay, starting context 7, what is your API key? In the top bar, you need to copy paste it in there, and it will not surface in your code base. This is how you define, that there's a special secret from input, and it has a name and it will be stored for you. And you can have a description and it will be at the top. Maybe I can show it later on. All right. Demo. Let's see if we can do this one. So, this is, by the way, how you see that you're inside of a dev container. I sometimes forget that, you need to watch the bottom corner, and for some reason, there we go. You see now that we're connected to a container, right? The one that we created. If I say now open folder, it says, well, you're in a container. So which folder inside of the container you want to open? So this is like, all right, okay, I was still there, so I need to disconnect. Go to the bottom, close remote connection, and I disconnect, and I can do open folder, and now I get my local machine again. Let me pick the right one. So here's the Azure DevContainers. There we go. So what I did, I took a sample that Microsoft built as part of the Azure Developer CLI, and it's the to-do application. And there's various stages in what you can do. But first I wanted to demonstrate what a more mature dev container JSON file looks like. So I added this dev container myself because it wasn't in the original code base. But the code base is an API with web. It has some infrastructural code with bicep. I don't have bicep installed locally. I don't have the developer CLI. Let's try that, right? Do I have bicep? I don't have bicep. Do I have, what is that, AZD? No. Do I have AZ? No. So I've got nothing installed and just default extensions here. So what I did in the dev container, and if I start the dev container now, there's a moment where it starts where we can't look at the file. So we'll look at the files now and then quickly start it afterwards. But we did this one, .NET 8 on Bookworm. If we look at what I have locally, I have 9 and 10 installed, no 8, but I just put it in my dev container, right? I don't need to have the old versions with me. This is what the sample had, 8. No, that's okay. I need Node, I need Azure Developer, CLI, Azure and GitHub CLI. So then that's pretty much what I need. I want to have all these extensions because these make sense now that you have an Azure extension, the bicep language provider for C# as well, and so on and so on. You know, you get the drift, right? So I just add these extensions here in the definition, some additional settings here. I have the MCP servers for context 7, which I did have installed locally with the prompt, and I have some forwarded ports, and also, we'll get to this, 2 scripts that run during the creation of the dev container and also after it has been created. So there's a life cycle to these dev containers where I can just like pick my moment where I want to do stuff. So for example, the on create, remember that we talked about the dev certs with clean and trust. This is what I do just, you know, when things get created. And after it's been created, I install an additional extension for AZ, so the Azure CLI, and I do a git pull to make sure that if I'm connected to something, get me the latest version locally. So no scripts that will be automatically started. Reopening container. If the pop-up disappears here, like, oh, you've got a dev container JSON, do you want to open a container? Go to the remote explorer or the little box in the bottom, and you can do that, and then we can say, go to the dev container. The first time this starts up, it needs to download the image. That's the very first time. Images are cached on your local machine. After that, it needs to install all the features. That happens one time if you leave the dev container image that's built locally around. So it's a volatile image, but if you don't kill your dev container instance, it will stick around. So lots of stuff happening here. It's just prepping everything and lots of outputs. Now it says activating extensions, and on the left, maybe make it a little bit smaller, you already see that there's additional extensions appearing, like Azure, Foundry, GitHub Actions. Those were the ones that we said should be there. The language provider, so if we now go to the main bicep, it starts lighting up because the language provider is also available. So we started from, we've got nothing on our machine, to we have it running here, and we can start using, let me do a new terminal. You can see that you can have multiple terminals. So this is Z shell. Ah, pretty terminal windows, right? So this is what I like. I want to have this. I just made this up, right? I don't really like it, but it's just for demonstration purposes. Different colors because this is part of my dev container. It's not actually. If you're familiar with dot files, the bash RC and the .z shell RC, those are files that define what this looks like. So let's do a different one. So this was Z shell. Maybe do bash. Bash is again different, right? So that's a different dot file. I have a repo for that. Where I have those files. And what I've done is inside of my settings, Settings. Ooh, let me see if I can find it. I might not be able to find it as fast because I think it might be. Where is it? Where is it? Oh, I think I know. DevContainer. Where is it? Oh, I'm overlooking it, I think. So somewhere in here, and you can either put it, oh, here. So here you can do the .files repository. And if you put in the GitHub URL to the repository, it will automatically clone it, put it somewhere, and make symbolic links so it just shows up in the right place. So if all goes well, bit messy demo, I apologize. But if you do this one, you see that there's a folder .files, right? That's the root. So if we do LA, so that's all the hidden files as well, you see, for example, that the bash RC is symbolically linked from the folder that we just saw to this .files cloned repository with bash RC there. So it appears to be in the right place, but it's actually coming from the cloned repository. And that's how I can put in my personalized stuff as well. All right. That is in the slides, but it's at the end, and usually I don't get to it, but now I just found this moment to do it. I wanted to show you that you can now do AZD. So it shows you all the stuff. So you can do AZD env list, say that there's stuff there that exists in this repository. So we can create new environments. Or let me think. Oh, AZ works as well. So that's why Node was installed. AZ. So everything is now inside of my my image. Sorry, my dev container here. All right, let's move on. How are we doing in time?
You're nearly there.
Oh. All right. 58? Oh. All right, so life cycle, I'll be brief in some places, but I mentioned multiple moments. So there's moments where your local system is initialized. You might need to download encryption keys or something, you know, before you start creating. So think exotic scenarios. You can do it. It builds the image. After it's being created, it gets started. So you can do post start. On create, that's when the dev container gets created. And finally, when they attach, even at the moment of connection, you can still do tie into this post attached thing and run a script there. So then you put it all inside of your .dev container folder, and your dev container JSON points to the names of the files and the names of the events. All right. Where it can be stored, we've seen at the top the workspace. That's part of your code base, but sometimes that's not that's not convenient. For example, if you have an open source project that you want to clone locally, you see like, okay, you need to install all these things. You're like, oh, let me create a dev container, but I want to contribute. So if you put your stuff in there, you need to take into account that you shouldn't commit it every time again, but you can keep it in the user data, which is outside. Think user secrets for your configuration files in .NET. It's outside as well. This is kind of the same thing. We saw the one with the image. There was the special alpine.json file that was stored somewhere. You can do that. And you can even match it to the repository that you cloned something from. You can have files for that as well. And the folders here are listed, special locations, but the slides for reference afterwards. All right. So then I'll end with this demo because I've done most of the other things already. But I think this is an important one. So hope you can bear with me, and I'll keep you a little bit more hungry. But left is local development, right is what we need in the cloud. So the example, something does need Cosmos DB. It might need other containers like AKS or Azure Container Apps. It might need Key Vault, blob storage, the list goes on and on and on. That's what your application needs. You can create a base image like we've done now that is able to connect to all of these things remotely. But you do need all the Azure resources, which is, okay, that's doable. But what about going even further, that you make this part of your development environment as well? So you can never, clone Azure or something, but you can emulate it, right? And you can do smart things. So for example, isolated development, that's where we want to go. So let's make this a little bit bigger. We'll still use .NET that wants to connect to Azure actual resource. Well, not anymore. We want to connect to those things, but replace them in some shape or form. So we'll use a local cluster like Minikube, for example, or K3D. You can use emulators like the Azurite, or maybe you have Cosmos DB or Service Bus emulator. And then you can just get rid of these, the top two. What about Key Vault? There is no emulator for Key Vault. But what does Key Vault do? Your .NET code takes this as a provider, reads secrets there, and puts them in your config. So you can easily fake that by having local user secrets, for example, which mimic the stuff that would be gotten from a Key Vault. Or you can have a separate JSON file that you mount into your cluster as a secret in your cluster, and it doesn't have to be secret because you're developing, right? And you're not really connecting, so you don't need real connection strings, but you do need a connection string to Cosmos DB, for example. Well, put it in user secrets or even in development.json or something, app settings.development.json. So composing locally means I have my original dev container and I start creating more supporting containers with the things that I need. So we talked about the emulators, and there might be other things like, for example, an OTel collector. If you're doing open telemetry, you want to have a collector, just spin it up as a container. And this is your composition. And then you tell Visual Studio Code, this is my dev container, and that's just it. But the container can connect to everything inside of the Compose network, which is a local isolated network, and they can reach each other by name of the service. So if you have this one like email, then you can connect to HTTP email, because that is a DNS service running inside of the network. So your Docker dev container JSON changes that you have a Docker Compose file, and the Docker Compose file will point to a file, whichever name you pick, inside of your dev container folder. That is also holding the dev container, that used to hold the dev container JSON file. So what you will do is create this Docker Compose, put your stuff in there, and this is essentially how you will wire it up. The rest of your dev container JSON is still customizations and features, because that's what this thing will use, and this is just one of the other containers that were run there. All right. Now I want to demo this, but when I try to, with the emulator for Cosmos DB, or it might have been Service Bus or SQL Server, like Azure SQL, this is an ARM laptop. And not all things are available as ARM images. So, some things can be emulated by running QEMU, or there might be ways out, but sometimes you just get, this image is not available in the architecture type of your machine, like ARC or ARM64. So, quick introduction, CodeSpaces does what we do on our laptop, but hosted for you. And I'll switch to the demo because I need to be there. I'll show you this Azure DevContainers, where we have this dev container JSON with a Docker Compose, where we have the Cosmos DB, like we saw. Cosmos DB, make it a little bit bigger. We have, that's the main one, where you configure your emulator. It has a name, Cosmos DB. and that will be wired in. And we have all the other things as well, like devcontainer JSON, loops that in, and it's pretty complete at this point. So what GitHub offers you is that if you go to code, and here you have this tab, instead of local and cloning it, you have CodeSpaces here, and here you can start a new CodeSpace where you can choose your branch, if you want to be on main or on starter, or the branches that are there, and the machine type, so 4 cores as a minimum in this case, and then you can create a CodeSpace, and it will start doing the same thing that we saw locally, except it takes a little bit of time. So I've done that before. That's what you saw when I did this here. You saw this urban goldfish. This is urban goldfish at the top here. So I can just restart the CodeSpace. It's been stopped because you pay for core hours. You for every GitHub license that you have, or a free account, even if you're on free, you get 120 core hours. So if you do 4 cores, you'll get 120 divided by 4, 30 hours for free per month. All right. So it's opening, restarting the container image, connecting to it now from a browser that looks pretty much the same as my Visual Studio Code, except it has a different color theme. I just wanted to show you that if you put in the settings, let me see where they are. Where are they? Oh, I missed them here. Where did I put them? All right, never mind. So you can change the theming of the thing as well. It has Cosmos started now, so there's a Cosmos emulator. I intentionally didn't try this, but if we go to Azure, it has these extensions and we can connect to it. Hopefully, if we go to Cosmos DB accounts, local emulators, new emulator connection, we can do connection string. And it is a well-known, publicly available, because it's an emulator, it's this one. So, never mind it's being recorded, because if you Google this, you'll find this connection string. It's the emulator's connection string, and we can connect to it. And fingers crossed, because sometimes you need to reload the window like we do now. But for the sake of time, if you restart your CodeSpace now, it will pick up on the emulator, and you can connect to it as if you are connected to the real Cosmos DB in Azure. And this goes on and on and on with all the other emulators that you might have, like Azurite for blob storage, queues, tables, all running from this. And this is from a browser. You could even run this from your phone with a browser. And if you project your phone screen on a larger screen, you can work remote with just your phone. It's not a plug for GitHub CodeSpaces, because there's other offerings out there as well. It just, to me, this is remote hosting of a dev container, and which I think is pretty cool, that you don't even need to have a laptop, or if, like me, you're stuck because your laptop isn't powerful enough or wrong architecture type, you can still work with this. And it's the exact same code base as we saw before, just now running in the cloud. So wrapping up. There's a lot of extra slides, some of the things we saw, so do take a look at the slides when these gentlemen publish them, so you can go through it in a bit more, your own pace, or have some thought, oh, okay, so this is what maybe we didn't talk about, or things that I skipped over or went very fast. But I think that, if you look at DevContainers, that you can do all the installation there. It gives you the flexibility to do your connectivity and exchange and configuration of your tooling. You can have it versioned and reusable, personalized and all. So all these things, you gotta love DevContainers, right? That's what I hope you take from this. So I'll be here for dinner and available for each and every question that you have. Thanks very much for being here. I hope you enjoyed it. And now it's dinner time, I believe. Thanks very much.
First, is question time.
Oh, it is.
We got at least some questions in the chat. Do we have some questions locally? Also here, let me get out. So I saw Christian.
Thank you for your talk. Can I also run a dev container on my own cluster that's, for example, somewhere in my company?
So the question is, can I run a dev container on my own cluster? I think yes, if it's connectable, connect to any container. If it's reachable, then you should be able to do so. It needs to have the VS Code server to be installed so it can be connected to. Didn't try it yet, but I think self-hosting in that way to stay away from GitHub CodeSpaces is definitely possible.
Do you also know if I would have any source code locally at the end, or is it just on the cluster?
So let me understand that correctly. You're concerned about where your code stays, right?
Yes.
All right. So if you are running on a cluster, then it's more stringent to what you can mount, and you can create named volumes. So you can have a volume where your files reside to keep them safe. Real access to the local file system of your cluster, probably not something that will happen, because how? So they're either inside of your container, and you need to, like we said at the beginning, make sure you get it out before the container is torn down. The named volumes, make sure that your volumes, they are a bit more resilient to shutdown of a container. And I think that's about it if you do it that remotely.
Okay, thanks.
So let's make one question from stream. Let's alternate.
So Reinhard is wondering, you have some issues with Visual Studio extensions. How do you deal with Visual Studio, mostly twice a week, having hiccups where the extensions host constantly crashes, and after lots of retries, trying to bisect the extensions, uninstalling, rebooting? How do you deal with issues? Have you experienced this? And how is the stability compared with other tools such as Rider?
All right. I think, did we all get the question? So online for sure. Let me just recap so I know what the question was. How does it compare to Rider? Well, I've tested Rider, and so I've got limited knowledge there. I don't use Rider myself. I did look at how Rider connects to DevContainers. What they do is also they do their Rider server inside to be able to do the connection, which is more than a gigabyte. And I even brought this to the team and asked them, why does it need to be so big? And they said early this year, so this year, they'll be working on trimming it down because they also realize it's much too big to have a small image and then doing a full gigabyte of a server just to get the developer experience running. It seems a little bit out of place. So they're working on it. Other than that, I think if they fix that, it's pretty much on par, but you have Rider with full IDE versus an editor such as Visual Studio Code. So very valid. To the other point, problems with extensions. I do know that sometimes there's, with all the activation of extensions in a dev container, that there's a race condition of things that have been started, like the emulator and the extension being there before the emulator really started. So that there can be some things I did notice, but can't answer that now, that they did find some hooks to delay certain things or wait for certain things to complete before starting the extension. So there is a hook somewhere. Google it, or ChatGPT or whatever, Claude, your thing, and that might help as well. All right, there were two gentlemen here.
So first, thank you for the talk. I have been trying to test to put up dev container a few times, but I will have one problem that when I do front end, then I have to download a lot of small file to node model. And when I don't know how many way I try, but the speed in the dev container is always so slow. So I don't know, it's my skill issue or it's a thing.
No, it's a thing.
Oh, okay.
So don't worry, it's a thing.
And do you know how to fix it?
Yeah, well, yeah. The way if you do a bind mount like we did, like mapping our local file system to the container, it needs to be transferred back and forth over and over again. And with node modules and large with numbers of files, it's slow. You'll notice that it's like compiling things if you have lots of small files. And it needs to transfer them back and forth. So it's slow. The way around it is not to do bind mounts, but to do named volumes, volume mounting instead of, and that make sure that it's in a storage that is maintained by Docker or Podman. It's a single thing, and they don't have to do the transfer back and forth for that. But that means that you need to make sure that your volume doesn't disappear, or that you do the git commit push before, because then you can lose stuff because it's not on your local file system anymore. Just the volume. But if you delete Docker Desktop or Podman, those files will be gone. So you need to be more careful, but probably you commit and push every day, right? Yes. Okay, good.
Thank you.
Agnes is wondering, is there a limit on how many MCP servers can be defined in a dev container? And are there any port conflict considerations when running multiple MCP servers simultaneously?
Okay, good one. I think that the MCP servers that you put in your dev container definition are essentially references to an MCP server. So they are either remote, and that works. If you have local MCP servers, you need to have something running locally, and then you point to that one as well. So those two options you have. Locally running ones, they can have port conflicts because they will actually be present there. If it's remote, it's just a URL with a port number, that will work fine. So that, and is there a limit? No, there's, I think, not a limit, but there might be practical limits. Like mentioned before, if you have MCP server with lots of tools underneath and you have multiple MCP server, it adds up and you start getting notifications on maybe you should, uncheck certain tools for certain situations because this is just a lot for the language model and the token transfer to work with. So it will be costly, more and more costly, because they need to transfer all the tools with every interaction with the large language model underneath. So it's a consideration, not a limit. And it will be less specific because the LLM needs to decide which tool it wants to use. And if there's just over hundreds of tools, it becomes more, non-deterministic even which one will be picked. So be specific, be lean.
If you remind yourself to the Key Vault in Azure, in the same pretty much subscription, let's say, I did create an Azure Key Vault and also an application service, okay, with certification, with password, which I will use it then in a CRM or a .NET application. How can I put this PFX file or cert file with a password into this process or container?
All right. Let me think. So the PFX file is for a certificate, right?
Yes, the one that you install in the hosting dev or prod or QA machine where the application runs. In this case, let's say I want to authenticate to SharePoint Online with Azure Application Service.
Okay, so it's not a .NET dev certificate, but it's a real certificate.
It's a real certificate.
Okay. So thinking out loud, but we might continue over dinner, right? But the things that I'm thinking of is decide whether you want to put it in your code base. If it's a secret thing, it might be password protected, right? But might not be smart to put it in your code base. So it needs to come from somewhere else. That's one consideration. And then you can just use, well, I need to think about it because you don't want to have the password stored anywhere. And that's a tricky one, I think, because you need to install the certificate locally with the password. So that might be a prompt or something that is put up afterwards as part of the script, where you need to do that locally. I need to think about it. An interesting scenario, but I don't have an full answer yet. Sorry.
One final question from the web. You may have answered it, or at least partially. Maybe there's something to add. How do we mount storage on DevContainers so that files generated on code are not lost?
Yes. All right. So this question is about the volumes and them being mounted. Yeah. I think that that's pretty much taken care of automatically. You can, well, if you start your containers manually, which you don't usually do, then you can be specific in your instruction, like we did, like in -v for the volume mount. If you clone from a repository, you use the internal tooling, and there is, which I haven't used much, but if you go to clear, you have the DevContainer CLI. Not here. Maybe I have it here. Let me see. Yes. So you can do a DevContainer up, and you can do the, well, that's probably the one that you need, DevContainer up. Sorry, I think I know. If you go here, here you can do your mounts. I blanked out for a minute. So this is where you do your mounting of volumes. So here you can do the, probably CodePilot will help me here. Here you can see some examples of how you can do the mapping, give it a name, and have a target and a source and a type of a bind mount or a volume mount, and the consistency that you choose. So that's how you would control your mounts from a definition perspective.
Good. Do we have additional questions here locally? No hands are raising. Let's give the chat a second or two. Nothing? Nothing here? Okay, then thank you. Yes, I would like to have the HDMI cable. Let's quickly switch again. So, image here. Let's make also that the people on the screen, on the stream, can see something. Yay! Good. Thank you, Alex, for giving the talk. Was very, and let's give another round of applause. And where is it? Somewhere in my backpack is a custom coaster from our logo. I will find it later. Every first-time speaker will get this. And thank you all for joining here at location and on stream. We had quite a lot there. Thank you again for Rubicon and JetBrains for sponsoring us. Let's do quickly the JetBrains raffle. Or do you want to say something? Okay. Let's quickly do the raffle. So last chance to enter the raffle. We have 7. So let's see who is the lucky one this time. Yes, again, as usual, I don't try to pronounce the name. Please contact us at team@.netdevs.at, and you will get in the next 2 weeks, I'm setting only expectations, the voucher code for it. Yeah. And yeah, with that, we are at the end. And I hope we see us next month when Patrick and Tim are talking about modular monoliths and fitness functions. Bye. And yeah, let's see what we have here for eating and drinking. Thank you.